Okay, so now we're going to talk about derivatives with math, okay? So, so remember again that derivatives are the slope of the graph of a function. So this is the slope of the graph of a function at every single point on this curve, okay? And so remember that rise over run equals slope, okay? So what we do is define the same thing. We have a rise over a run, okay? So the difference is that this rise over run is infinitesimally small. And so you can go back and look at the conceptual video to see what it means for this to be small. But basically you zoom all the way in until you see a line, and then you can do the rise over run there. Okay, so it's a very small rise over run. That's what this limit of h approaches 0 means. A very small rise over a very small run. But that still ends up being something that you can calculate. And that is what we call the derivative df dx. And that's how we denote it. And this is very similar to a notation. This is very similar to a notation like this. Delta f over delta x. Okay? So this is the change in the function over the change in x. So this is what we call a rise over run again. Okay? Except this one is finite, and this one is very small, rise over very small run. Okay? And so that is how we denote slope. And so if we look at this picture, this is the graph of f of x. When h is not really small, when it's not approaching 0, then we have something that's very similar to how the graph is acting at x naught, okay? Which is just a given point on f of x. So we know this is very close to the slope, but it's not exactly the slope at that point. So what do? What we do is just get in a little bit closer. So we give a new h that's a little bit closer, and another one that's a little bit closer, and another one that's a little bit closer, until what happens? Well, we get them so that h is basically right on the dot on x naught. And so the line that goes through both x naught and x naught plus h basically only hits the curve at one point. Okay? And this is what we call a tangent line. That's why we hear the derivatives referring to the slope of the tangent line. Really, what does it mean? It means it's the slope of the function at this small point. Okay? And remember that there's 2 points there that get almost to 1. Okay? And so there's one that's at x naught, and there's one really close to it that's x naught plus h. And so there we can do a rise over run. So f of x naught plus h is minus f of x naught is the rise, and the run is h. And we just take h to get as small as possible so that we can have as small as possible rise over run, so we can get right on that point, so we get a tangent line. And this is derivative of the function as long as we take the interval to be very small, and this is evaluated at a specific point. Okay? And this is the evaluation symbol.